All right, good morning, everyone, and thank you for joining in on our EDX webinar on the converging of LMR and DMR with LTE. I know Brian has some good topics to cover here throughout this webinar, and as always, there is a Q&A button within the Zoom webinar panel that at any point you can type in a question and we'll either answer it, directly here in the webinar, or we will also try, if it's something more direct, we can answer it direct to you through that Q&A window. So feel free to go ahead. If any questions come up throughout the webinar, please use that Q&A panel and ask them, and we'll try to address them as they come up so that we don't get too far away from the topic where the question is. And yeah, at this point, I will pass it over to Brian and we'll get started.
Thanks, Rory, and thanks everybody for joining. I see some familiar names on the attendee list, as well as some new names, folks I haven't talked to yet. So welcome, and thanks for joining today. What I've got today is going to be mostly sort of SignalPro heavy, showing you an example, a hypothetical project that I've put together here to look at from the perspective of if I am an LMR operator, maybe I've got a traditional VHF or UHF mobile network, and I'm looking at adding an LTE overlay or even really 5G or NB-IoT. Those workflows are going to be very, very similar. And so I'd like to sort of take you through that exercise and show you the high points of how to set this up and approach an exercise like this. And then at the end, I'd like to open it up to some questions. And I'm specifically going to sort of ask folks to reach out to us with their use cases and how we can take the planning sort of further from this point. So let me go ahead and just start with the slides here so that I don't just totally go off the rails and shoot from the hip like I might sometimes do. So the use case that I want to look at today is, like I said, I've got a VHF land mobile system in, I picked an area that's a really difficult area to cover 100% of because of the terrain and because of the clutter. And so in order to make any kind of LTE coverage across a wide area like that, what I chose for my LTE technology is actually the LTE 450. And so this is band 31, which is, I've given myself 5 megahertz, hypothetically, of band 31, which is an FDD band. So I've got 5 megahertz in either direction. And it's at 450 megahertz. So I'm not stepping up in frequency a huge amount from what's existing. But as we go through this, I'm going to talk about if we're looking at sort of broadband frequencies instead, or if we're looking at IoT sort of use cases instead, what might be a little bit different there. And I'm just going to sort of go through the workflow to getting to a finished sort of planned private LTE design and talk about how you might go about rolling out that deployment and sort of expanding out your network coverage. So these are the tasks I've sort of laid out and identified. Are first to choose the mapping data and the propagation model that you're going to need for that higher frequency band. If you're using the same spectrum and just adding a technology, well then great. Your current propagation modeling approaches that are working, let's say you're working in UHF and then you're going to swap some of that to a private LTE technology, well then maybe your propagation model doesn't need to change that much if the path loss you're getting is good for that frequency. But if you are stepping up to a higher frequency band, it's quite likely that the propagation modeling approaches and maybe the mapping data that you need are going to need to be improved. And so that's sort of your first task when you look at doing a project like this, coming from sort of a more traditional LMR, especially a lower frequency band. Once we've set up our model, then we're going to select some site locations to cover as much of the county, which is the service area I gave myself was 1 county. We're going to cover as much as possible, but we have to keep that within budget. And so we're going to look at how we can use the automatic site selection that way. And then we're going to run some predicted coverage and data rates for both mobile UEs and for some fixed UEs, and then do some PCI and neighbor list planning. So let's go ahead and jump into this and talk about that propagation model and mapping data selection. So in this example, since I'm going to be working at 450 megahertz, I'm using our Cirrus subscription 5-meter resolution data. And if I show the terrain here, you can see what's interesting about my area of interest. All of these hills from sort of glaciers sliding across here in the ancient past made it so that this is very, very hilly and difficult to cover. You know, there is one sort of really high spot in the county that has a good overview of the entire area, but otherwise it's sort of rolling hills topology. And on top of that, since this is basically Bremerton, Washington, we've got an awful lot of tall trees as well as we get out into the kind of suburban and semi-rural areas here. So I've set up to use our Cirrus 5-meter subscription data, which for bands, you know, say 800 megahertz, 700 megahertz or less, this data is going to be really suitable to mobile use cases and kind of a wide variety of different use cases that you might deploy for those bands. If you're getting up over a gigahertz, and especially if you're in more urban areas where you have a lot of tall buildings or a lot of variability in the heights, then it might really make sense to switch to a custom data set that has those clutter heights built into it, so that for every grid cell, we know what the height of the actual buildings or trees or whatever are. And I've talked about that in other recent webinars, so I'm not going to derail the conversation to go show you some clutter height data or some really super high resolution data. But just bear in mind that sort of I would consider that to be one of the important breakpoints, is whether you're sort of above or below 1 gigahertz, and then also thinking about how close to the ground the UE equipment or the remote equipment is going to be, and whether it's moving around or fixed. You might select a different data set for that. And of course, EDX is here to help you with that custom data if you need it. You can reach out to your sales account manager and give them the area of interest. You know, if I were to send this polygon to Rory and say, hey, what are my options for data for this area? I'm looking to get some clutter heights. He can come back to me with sort of a menu of what's available and some pricing on that. Or if I've got my own GIS department in-house and they can provide that data to me, then we have that conversion path to be able to bring that data into the tool and create your propagation models and everything. So if you run into that situation where you're trying to bring in your own GIS data, do feel free to reach out to us, either, again, through your account manager or just through the support portal on edx.com. If you have some really high quality data to use in your planning, then we want to help you do that. So in terms of the propagation model that I chose for this, with my VHF system here, I've been running my predictions using the Anderson 2D. And if I highlight this one here, you can see I'm using the add clutter loss to get the traditional TSB88 clutter losses for mobile from, you know, a mobile down at ground level that might be next to a building or under the trees or whatever. So I'm doing those location-specific losses, but then I've also added on this pass-through clutter loss in order to account for my areas of big, tall trees and buildings and that kind of thing. Since I know I have a lot of grazing paths in this rolling kind of morphology, I wanted a nice conservative model, and so I added that clutter pass-through loss. And I think this model, assuming that I adjust the height values for my clutter types and I adjust the loss values for those pass-through losses, I would want to come in here and make some validations and some adjustments on those pass-through losses for evergreen forest or mixed forest, what have you. And then use the test against measurements function, if at all possible, to bring in some field measurements and make sure that the path loss model I've got is correlating well with what I'm finding out in the field. And now, you know, again, when we're in a lower frequency band, it's sort of easy to adjust and tune the model and have a high confidence in it. As you go up in spectrum, you know, if we start looking at 4 gigahertz, then it's going to be really important to know where we have line of sight and not. Those clutter heights get more crucial, and the loss values we've seen from talking to our current users, the pass-through clutter loss values become more variable as you go up in frequency as well. For certain bands, you'll get more or less loss for certain clutter types, and that'll change pretty drastically from one market to the next. So it's important to try and make some kind of validation of your propagation model, either using CW drive test data, which is great. If you're already set up to gather that for your land mobile networks, then usually it's not that big a leap to be able to gather that for your new LTE equipment as well. And you can use that test against measurements function right here to import that and make sure that, most importantly, the mean error between predicted and measured is as small as we can get it, something approaching 0. And then that standard deviation tells you sort of how much more variable the real world is as compared to your model. So that helps you decide on maybe building a little bit of design factor, extra margin into your model. So that's an important step, especially if you're stepping up in band really drastically. Another alternative here, let's say you're stepping up in band really drastically, and you don't have, or there's no money in the budget for super high resolution clutter data or clutter with heights. Another alternative here, I'll use this third line, is the 3GPP model, which is available here down toward the bottom of the list. This 3GPP empirical 5G is a distance-based model plus terrain diffraction. So it's still going to take your terrain into account, which a HADA type model, traditional HADA models don't. But the 3GPP model will take any hills into account, and then also they have some loss curves built in that can be essentially used in place of high resolution clutter data. So I just, I could select my rural macro here. The thing about it, though, is that the 3GPP model does not go all the way down to 450 megahertz. This is more appropriate if we're looking at, 1900 megahertz or 4 gig or something like that. Then this 3GPP model is a great choice if you don't have really good high resolution clutter with heights, but you still need a reasonably conservative, reasonable estimate. This is, recommended by the 3GPP as a good empirical method based on measurement data. So in my case, to use a method similar to that for 450 megahertz, just as a way of showing you an alternative to having super high resolution clutter data, I went ahead and set up if I choose the custom model here, I can get a HADA type custom model, and under supplemental data, I can go in and add the terrain by doing this include diffraction and reflection, and then I choose an environment switch, and I can set up whether I'd like to use the HADA curve or the COS 231 curve, which you would choose kind of based on frequency band. And especially if you're in a dense urban market and you don't have that high resolution clutter, this is going to be a much more reliable approach than trying to use the Anderson 2D and account for clutter that might not be granular enough to see line of sight or not. So just, again, as an alternative, I wanted to show you this HADA plus terrain method here. And that's what I've set up for any of my LTE equipment. When I set up my template for my eNode Bs, I went ahead and chose that HADA plus terrain propagation model. So, and that's the model options choice here, is whether you've got clutter that is good and has the heights built into it, or good for the frequency band you're using, and you're going to use that clutter to find your path loss, or whether you want to use a more empirical model like the 3GPP. And then, of course, the model tuning and validation is how we prove we've chosen a good approach. So moving on to setting up the actual LTE equipment, if I jump back into my project here, we'll look at my Gold Mountain site. And what I have initially here, what I had in my project to start out with, are these 140 megahertz traditional LMR sites. And I think I had 4 sites to start with that are shown on the map right now. And so what I did was to take those 4 site locations and create a template for what an LTE eNode B would look like. And so, again, since this is the LTE band 31, I chose a frequency of 460 megahertz. I just kind of picked the middle of the band, or the high end of the band, I should say. And then under system name and type, I select LTE Pro here. If my equipment is actually 5G, then it would be exactly the same, but I would select 5G and go under the 5G menus. Or if I'm doing NB-IoT, which is basically a narrowband LTE, then I would select this and go into the NB-IoT menus. But other than that, this workflow is all going to be exactly the same. So I'm going to choose the LTE Pro, and we want to make sure and choose the Pro to get the current version of it. And then also, I'm going to choose a MIMO and adaptive antenna selection. And once you've chosen these selections on your template or on your sector equipment, then you want to go into the network design analysis menu and the RF systems menu and define the configuration settings for your LTE RAN node settings and the MIMO type that you're using. So let's go look at the MIMO type first. If I go under RF systems, MIMO adaptive antennas, we've got here a bunch of pre-populated values that these are sort of from the MIMO equipment vendors specs on the kind of improvement gains that you could see from that MIMO configuration. The one I'm using, just for example, is the MIMO A 4x4, which gives me some downlink coverage gain and some uplink coverage gain, and is not going to have any impact on the data rate. If it's not doing the spatial multiplexing. If I were to choose MIMO B instead, then you can see here I get some gains on the coverage, but I also get this throughput multiplier. And importantly, that's going to be taken into account when we run the data rate study. So just bear in mind, if you get a data rate that looks higher than what you expected, make sure and check this throughput multiplier is not only correct for the equipment, but also reasonable for the amount of multipath that you're going to get in your environment. Typically, the MIMO antennas will perform better under higher multipath conditions. And if there's not much multipath, it's not going to get quite the performance improvement that the manufacturer's spec might imply. So again, take these numbers with a grain of salt and adjust them as needed, but keep an eye on what the multiplier is for your MIMO type. And if the equipment you're using has a MIMO type that's not shown here, that's just fine. You can go ahead and modify these values and create some custom MIMO types that you can then go assign to the sector. So I would set up these values and then assign that MIMO type to my template that I'm setting up for the site. And then under Network Design Analysis, LTE Pro, I want to go to the system details. And here again, I want to choose that system profile of 31, subcarrier spacing, and a 5 megahertz bandwidth. I've created a channel plan template that just defines the spectrum that I have, just gives me a single channel to work with. And if I need to make one of those, I can do that right here under the Utilities menu, Create, Edit, Channel Plan Template file. So that allows me to specify sort of the basics of the band. And if I'm not going to tinker with anything else, then I'm ready to go. If I want to dig into the configurations and use a sort of a non-custom configuration, that's where this RAN import comes in. And you can see I'm pointing to a spreadsheet here that I've set up. And if I open this up, this is my RAN workbook. And what we've got here in the Technology Template tab, I define the different bands, the different technologies that I'm using. So in this one, I've got band 31, which is an FDD band, and it refers to my CQI uplink and downlink tables. And these are standard from the 3GPP standard, but if your equipment does something custom, if it disables certain modulation types, or it has some reason that you need to modify this table or extend this table, you can do that. Again, these values are from the standard, so for most applications, they're going to be correct. And you can see I've also got band 48, or CBRS. I put that in here. And the difference there is that this is a TDD band, or in other words, time division duplexing instead of frequency division. And so that means my spectrum is split between uplink and downlink, which means that I have to define the frame and how much of that spectrum, or how much of that frame is uplink versus downlink. And I can do that right here under this TDDC, that's TDD configuration 1. And here is where I can adjust the slot configuration. If I was putting up road cameras or something like that, then I would want much more uplink data than downlink. And so I would switch around this slot configuration to represent that. And of course, make sure you use allowable configurations under the standard. But then since my band 31 is an FDD frequency division band, then that's great. I've got spectrum devoted for uplink and downlink. And let's see, let me show you how you can then assign these technologies. If I had more than one of these technologies in my project and I wanted to assign, maybe some of my sectors are going to be band 31 and others are going to be band 48, then what I can do is, I would make the modifications to that RAN node spreadsheet and then just use this import button here. And that spreadsheet is just kind of the most comprehensive, easy way to look at everything all together. If I go into sectors here, I can see which sectors have which technology profile assigned, and I can do that by group as well. So if I go to my LTE, I'll say phase 2 group, you can see that these are all defined as using profile 31. If I wanted to swap some of these out to CBRS, I would just change that to band 48. So, you can make modifications to the technology or any of those sort of things that were their own tab in the RAN node spreadsheet, you can get at right here as well from these menus. But if you want, one way to put all those settings together and then send them to one of your coworkers, for example, you can save that RAN node workbook and somebody else can point to it for their project. Or, I've made a few versions of this that I can point to when I create a new project. So that would definitely be a recommendation if you're going to work with a particular set of LTE equipment. Go in and set up that RAN node spreadsheet for it, and then keep that as a gold standard that you just point to from all of your projects. Okay, once I've got my technologies defined and I have applied that technology either to any sectors, if I have some pre-existing sites, then I can just go ahead and apply that technology to them. Or I can go ahead and create new sites. If I set my template up to use that technology, then when I create new sites, they'll automatically have that band applied to them and be ready to go. And so the exercise here, just to kind of take you through the story here at this point, I'll turn off my land use and terrain data. And I've got, I think, 4 sites on the map here because I'm showing just my VHF sites in my transmitter layers here. And so if I show the received power that I've run for those, even with my mountaintop site here and some other sites to fill in, I've got some areas that are hard to cover in this example, and that's fine. If this is not a public safety network, this is a private network for some other purpose, maybe I don't need to get to 95% coverage. And so if I want to go ahead and import some new eNode Bs onto the existing sites, I can do that through the spreadsheet editor. But I already know that with the much smaller footprint that my eNode Bs are going to cover, I'm going to need some more sites. So what I can do at that point is go to databases, towers, and poles, and I can import a list of candidate locations where I could put those eNode Bs. Those might be streetlight poles or utility poles or what have you, depending on what's available. Or if you are going to be leasing space from traditional tower assets, from cell towers, then you can actually include as part of that towers poles spreadsheet the relative cost of those different locations. So what I want to do is bring in those towers and poles, which I import those through databases, towers, and poles, and you can bring those in from a CSV or a Google Earth KML. And so those are my tower locations, and I've got a whole lot of utility poles to work with, in addition to these 4 sites. And of course, if you've already got 4 deployed locations that you can easily add an eNode B onto, that's where we would most likely start. So I could just go ahead and add sectors onto those through the spreadsheet editor, which I've done. And then the next thing I wanted to show you was using the automatic site selection when you have existing sites in place. So if I know that I'm going to put an eNode B on each one of my 4 existing sites, and I don't want the auto placement to try and, be redundant. I don't want it to try and cover those same areas. So what I've done here is gone into network design, auto placement for areas. And under propagation, I choose the propagation model and spacing that I want to use. And then for my router candidates, I chose the tower and pole database that I've already set up. And then I choose the UE equipment. So I've gone in under RF Systems Mobile Remote and set up my vehicle-mounted mobile antenna that I want to use as the baseline for coverage. And now this part is important when you're running the router placement across a large area. You can see the total number of points in my study grid when I've got 3,000 and some points by 4,200 points. The total points is a big number. And we would not want the automatic site placement to look at several thousand poles trying to cover each one of these individual locations. So we use this sample reduction size to bring that number down to, in this case, it looks like 56,000 points, so that it's basically using larger bins to try and serve when it does the automatic router placement. And the right value to use here is sort of whatever gets you, I would say, into the tens of thousands of sample points, as opposed to hundreds of thousands or millions. If this number gets too low, it'll be kind of a coarse selection. And if it gets too high, it'll just take too long to give you an answer. So you try to find a happy medium there. And of course, I've plugged in my boundary polygons since my county is kind of long and skinny here. I only want to look at the areas within the county that I care about. And so I set up all of that as kind of the initial setup. And then under run auto placement calculation here, we've got a bunch of options. The important one we want to look at today is this use installed routers in selection process. So again, if I already have 4 site locations and I know that they're going to have eNode Bs, I essentially want to place additional sites around those and try to fill in the coverage holes that are missed by those original 4 sites. So I can check on this use installed routers in selection process, and the group that I choose, I called this LTE phase 1. I put an eNode B on each of my 4 towers, an additional sector on each of those 4 existing towers, and I put those into a group called phase 1. And if I check that on, then it's going to use those routers as it does the selection. And then I would check on create new group with name. And, you know, whichever phase I'm doing here, I could say automatic placement for LTE phase 2. And I choose the template for that router or the eNode B that I set up. And this checkbox, include installed as members of group output, what that means is that my 4 initial phase 1 sites will also get included in the phase 2 group that gets created. So my phase 2 won't be exclusively the new sites, it'll be the new sites plus the old sites. If you want that new group to only be the new sites, then you can do that as well. And you could make a 3rd group that combines them or whatever you want to do. So if I check that on, what it's going to do is try to create a phase 2 group that's got those 4 sites plus whatever additional tower locations are needed to fulfill the threshold, the criteria that I've set up. And then down below here, you've got 4 different methods for purely coverage driven, coverage plus capacity driven. There's one specifically for IoT that I won't dig into how that's different because it's a whole rabbit hole. But and then the method 4 here, which is the one that can take advantage of those costs. If we've got different relative costs on the sites, the method 4 is going to be the one that can take that into account. And I won't run that right now because it takes a while to get through the propagations and present me with an answer. But it's just like a cooking show. I baked one of these earlier, so I can go ahead and show my LTE phase 2 group now, and we can see where it added in some sites. Oh, and I forgot to show you one item. Let me go back to the auto placement calculation and run. And in this method 4, the other thing I wanted to talk about there, so this can take into account costs, which is why it's called the local greed algorithm. But the other thing that this can, excuse me, can account for is if we don't have enough budget to cover the full area, and we know that. So over here under my stop conditions, I've said stop when you get to 90% coverage, but also stop when you get to 25 sectors. And that would be another phase. If in my initial run, I told it to stop when we get to 11 total eNode Bs, because that's all the boss gave me money for, right? And I'm going to try and cover as much as I can with those 11 sectors. And so rather than just placing sectors until it hits whatever benchmark, it's going to do the best it can. Or if it hits the 90% first, let's say it places just 9 eNode Bs and then it hits this 90% metric, then it would also stop and show you the result. So these stop conditions here, the stop on sector count, this is how you keep it within budget and see how far you can get within that budget. So I didn't want to leave that piece out of it. And this is the collection of eNode Bs that I've got. And if I drill down into these here, I've got my LTE Pro set up. I've got my MIMO A 4x4. I didn't do anything fancy with the antenna. I left them just set as omnis. I should say that for a real deployment, you really would want to go get the latest antenna pattern files from the manufacturer and bring those in and point to that as part of your sector template. The vertical pattern can be important, especially in a project like this with a lot of terrain variation. That 3D vertical pattern can be pretty important, even if the sites were omni. But of course, most LTE sites are going to be sectorized, so you'll want to use that antenna pattern here. And if you had like a 3-sector configuration of this, that would be fine. I would just create 3 sectors on the template, and those 3 sectors would be oriented to some default compass headings, and they would all point to that same, LTE Pro system type and MIMO type and everything. So once I've got those on the map and configured correctly, there's one more piece I wanted to point out about the configuration, that this is an easy mistake to make. If we are working with, whether we're working with FDD or TDD, it's very important to get this noise, equivalent receiver noise bandwidth. This is the channel bandwidth here. And this is used to calculate not only the noise floor in the link budget, but also if you're working with a TDD, if you're working with an FDD configuration, this is how the software knows how much uplink bandwidth we've got. And on the mobile or the UE side, if I go over here under mobile remote unit, the equivalent receiver noise bandwidth here is telling us how much bandwidth we have on the downlink side. So it's important to get those configured correctly. And in addition to the other link budget parameters, your actual maximum allowed transmit power and gain and all of those details. Once I have those set up, I can go ahead and set up some study types. And to add one more wrinkle into this, let's say the boss says, oh yeah, we have these locations, these customer terminal locations where they want to put traffic cameras or whatever, some kind of fixed equipment out there on the map. If I want to do that, then I can just go ahead and set up a CPE type for a fixed UE up on a utility pole, and then I can go ahead and import those as CPE locations through the spreadsheet editor. And you can see I've done that. I've created some CPEs off of that fixed UE location, and those are going to be higher above ground level than my area studies are run. And so to get those both defined, I would go ahead and go into the area studies menu. And I've already got these set up, but I'll go as though I'm adding a new one. If I go into add study, I want to go into the study group for LTE Pro here. Or again, if I'm doing 5G, then I would use the 5G group, or if I'm doing NB-IoT, I would use that group. But the one we want for 4G LTE is going to be the LTE Pro. And under the study names, the important ones here are the RSRP, RSRQ, and the data rate for both the uplink and the downlink. Most of the time, these are going to be sort of the greatest hit deliverables that people will ask for. If we need to do aggregated throughput, if we are doing, in other words, multiple bands, and we need to look at aggregating that at the UE, we can do that. And then further down, if we go back and do some PCI code planning, and we want to see those PCI code areas displayed on the map, that's what we have a PCI planning study here for. That actually just displays the results of that PCI code planning. So I have set those up to use my vehicle-mounted mobile UE here. And you can see originally I had my receive power for my VHF incumbent LMR system. And now I've made some other studies that I have chosen the LTE Pro group and given them a label down here to just say clearly, you know, what each one is. I could label this, for example, LTE downlink throughput, etc. And I've got RSRQ, RSRP, etc. Oops. Oh, that's okay. I just changed my label, and I misspelled it too. So let's go ahead and show these study results here, and I'll do the set for status bar. And if you look along here, my color scheme, I use the same color scheme for the uplink and downlink throughput. We're ranging from anything below 25 megabits per second, we're calling that red and non-functional, and anything above 145 or about 150 megabits per second is the dark green. And you can see on the downlink side of things, I've got pretty decent coverage. There's some places I'm not going to be able to get great data rates. But of course, because of the imbalance in the link budget, the difficulty is often on the uplink case. And so with those 11 sites, the best I can do is sort of this kind of coverage here on the uplink. And so at that stage, then you could sort of go back and do the next stage of planning, saying if we get budget for another round of eNode B deployments, where would we want to put those? Then again, I would just come back to my auto placement for areas here and use that installed routers and selection process. But now I would say use my phase 2 as the installed and go create me a group that is the phase 3. And so that's kind of the exercise that I went through here to start out with some initial tower locations, see what kind of performance I was going to get, and then densify the network from there, which seems to have been a really common story in talking with our users and our operators so far. at that stage, once we have sort of initial coverage and site selections, excuse me, 1 second. Wanted to make sure Rory wasn't trying to talk to me in the text. Once we have those initial site selections, then oftentimes we might want to do PCI code planning and neighbor list planning. And in order to do those, I would go into, again, the appropriate module here. And under PCI planning, excuse me, I'm losing my voice already. I can set up my minimum RSRP threshold to be considered here. And then we have some sort of under the hood default values for the different kinds of conflicts that this can choose to solve for. And generally these default values should be okay. But for example, the reuse distance is going to vary drastically as you go from, you know, LTE 450 to 1900 to millimeter wave. The cell reuse distances like sort of really radically change. And so you're going to want to look through these values and make sure that they make sense. The weighting parameters, you typically don't need to adjust that much. Those just kind of adjust how the algorithm does its search. But especially the SINR threshold and the reuse distance, you want to make sure are appropriate to your use case, your deployment. And then you would go ahead and import the RAN and then run this, and it comes up with some PCI and PSS and SSS codes. And you can go ahead and it'll show those in the proposed column here. It'll show the current in their columns, and then it'll show new ones in the proposed. And you can choose to go ahead and apply those or not. And then for the neighbor list, it's real similar. We would go in here and make sure and import that RAN and choose the transmitter group that you want to work with first. Because, you know, if I do my neighbor list for phase 3, it's going to be much different than phase 2. So make sure you've got the right group of transmitters selected, and then you can go ahead and run that. And here again, your values may want to change in here. How much overlap you want to allow for may want to change, but typically the default value is going to be okay. And so, you know, I can show any of these different metrics on my map and show what kind of coverage, what kind of performance we should expect for a given phase of that rollout. And to address those fixed point to multi-point items, remember I had imported customer terminals here, so I can do the exact same thing with my multi-point studies. I can, if I want to, I can assign those fixed UEs to a specific server. I can go under the spreadsheet and say, okay, this UE is talking back to that server. And if I'm doing that, I want to choose the assign server option. If I want it to just run using the strongest server as the assumed server it's talking back to, then I would set that here. And this works just like the area studies. I would go in, choose the LTE Pro study group, and here's my RSRP, RSRQ, downlink and uplink throughput, etc. And so I set up the ones I wanted to show. Oh, and that's another one I like to show when we're talking about fixed here, is the minimum CPE antenna height for line of sight. Let's say we were doing like a 4 gigahertz product, and we'd really like all of our fixed subscribers, maybe they're up on utility poles, and we want to know which ones have line of sight and whether we can get them line of sight by putting a slightly higher antenna. So I set up my display style to be, okay, if we've got line of sight between 5 to 10 meters, 10 to 15, or above 30 meters, I'm probably not going to install a pole that's taller than that, so I made that red. And if I go ahead and run that then for those CPEs, only show this study layer, you can see which ones are going to be easy and which ones are going to be difficult. You know, if these ones in red, I would need a pole taller than 45, or a pole 45 meters tall to serve that one, and 475 meters tall to serve this one. So I don't think my field guys are going to be happy with that work order. So this one I'm going to have to come up with another plan or place another eNode B for, if I'm trying to get line of sight. I also, just to keep things simple on the multi-point ones, I went ahead and ran my uplink throughput, because that's what would matter for a road camera. And for the most part, most of these CPEs have a decent data rate, except of course that one that's down in deep hole that's showing as 0 megabits per second here. And if I drill into that one and show its path profile, I suspect I'm going to see that, yeah, that's grazing over a couple of pretty big hilltops in addition to the clutter. So there's kind of going to be no way. So this has sort of been the workflow for this. And if I want to look at capacity and traffic planning for this area-wide network, I can do that under traffic loading here. And essentially, I can set up some definitions for the different user types, which you can see I haven't done that in this one yet. I haven't done any traffic planning. But I can create a couple different user types for road camera and push-to-talk user and whatever different types of service I have on there. And then under the densities, I can put how many users per square kilometer I want, or how many users per square kilometer in the different clutter types. If I switch this to a different or to use the clutter for this, then my densities, I can say how many voice users we have per each clutter type per square kilometer. And in that way, I can then run this traffic loading, calculate average traffic load on each sector. And what it'll do is calculate the coverage footprint of each eNode B and load that amount of assumed traffic back to the sector, so that you can see how heavily loaded that eNode B would be and whether you need to add another one. And I should point out our auto placement, you can use that capacity limited method so that you could get enough eNode Bs to serve the capacity here as well. If we are doing a fixed multi-point, then we can also load that multi-point traffic from the CPEs back to the sector to see how heavily loaded those sectors are as well. And so in this way, we can get some predicted sector traffic. And then if I want to, I can run those predictions using this load-based noise rise. I've gone into my sector receiver parameters here. And if I, whoops, turn that back on. If I look at this noise rise curve, this is the curve from the 3GPP recommendation that says, oh, as your cell approaches 100% loading, you're going to get more and more noise, which is going to reduce the signal-to-noise ratio. And you can take that into account in your predictions here. But first, of course, we would need to do that traffic loading based on either some fixed CPE subscribers, or if we're looking at mobile, we want to distribute some assumptions for how the users are distributed across the area. And here's the point where I want to open it up to questions or invite you to reach out to us if you have a traffic and capacity planning challenge or a real world use case that you're trying to figure out how to approach this in SignalPro. I'd love to talk with you and love to talk through some more of those real world capacity use cases as folks are starting to get into these private LTE networks. Because the one thing I've seen as I've dug into this is that there are a ton of different use cases and a ton of different options for how the equipment can be configured. And with that flexibility means we can have multiple use cases on one system. And so I'd really like to get a better sense of how our current users are, or what sort of challenges our current users are going to be facing in the coming year or two, as far as capacity planning for these mixed use case types of systems. So with that prompt, I'll shut up for a second and open it up to questions. Rory, did any questions come in on the chat there?
Yeah, I haven't seen anything specific come in yet. As far as what would need to be answered, in the meeting. So if anyone does have any questions, feel free to pop them in. We'll give you a few seconds here to make sure we can answer them. And as always, I mean, we can always connect after the webinar and go over anything or answer any questions as well.
It either means I've been entirely clear and concise, and it was perfect, or the questions are so deep that everyone's going to reach out individually.
Yeah, it's a broad topic for sure.
Yeah, and I sort of wanted to for today's session just walk through kind of the workflow and how you would do this overlay. And like I said, I think that the mixed mode traffic and capacity planning is where the questions are coming in that are a little tougher to answer. So I encourage folks to reach out to us with those if you've got a case sitting in front of you.
Yeah, definitely. I see Jeff. Jeff, you've raised your hand. Was there a question that you wanted to pop into the questions panel there? Oh, looks like that might have been accidental.
Oh, okay. Yeah, it's kind of tough when attendees can't talk. I'm never sure if I'm giving people enough time to type their novel of a question.
Yeah. Well, it looks like for now we didn't have any questions, but if there are anything if there is anything specific, again, feel free to reach out to us through an account manager, through our support portal, or even through the info@edx.com email. Any of those methods will get back to us. For me, I just wanted to say thanks again, everyone, for joining. Appreciate everyone's time today. And Brian, did you have any parting words?
No, thanks everybody for joining. And again, if you've got a use case sitting in front of you that you're not entirely certain how to approach it in our software, I welcome you reaching out and would be happy to have a conversation about it.
Excellent. Well, thanks again, everyone. And, take care. Have a great rest of the day and rest of the week. And we'll see you in the next one.
Thanks, everyone.